when I had the stroke in order to finish out the semester because I was off work for quite a while when I had the stroke, and because I missed that there. It's kind of strange. The semester I had the stroke, I was back to work after about a month, but I was using a cane and everything else. And then last semester I was pretty okay. This semester I've had a lot of stroke fatigue and a lot of problems. So that's why it's my last semester. Okay, I'm going to pick up where we left off. I doubt if my pen works today because I haven't had an update on Windows, but we will see if it does here in a second. If not, we'll... Oh, I didn't want that. Let me get back to where we were at here. It's funny that I think my wife is looking more forward to me retiring than I am. Okay, let's see. Pen don't work. All right. I didn't think it would because there wasn't a Windows update. Oh, that's there. Okay. Just a reminder for those who are walking in, and for sake of the recording, I guess next week is semester break. Is that true? So you're all going to go back to compound, Molly compound? That there. My compound is Dato Karmat. I guess actually my first place I lived in Malaysia was Kluang and Johor. So my wife keeps saying that that's my compound, that there, because I lived there for about a year and a half. I taught it was now UTHM, but that was back at like 1997 or something like that, before many of you were born, I think. Yeah, that there. And then I lived a year in Bansar, Pantai Hill Park. I taught at Uniten. Then I went back and worked in the U.S. until I took early retirement. Okay, I'm going to go through this game of craps. The whole idea here is just so that I can explain the program. It's a gambling game. Don't go and practice it there. Don't go up to Genting Highlands and start playing craps. I guarantee if you play long enough, you'll lose. Right there, it's there. I mentioned the other day in class the law of large numbers. Which means that you could go up there and you can play for, 3-4 games and may actually win some money. But if you stay there all week and play continuously, you're going to lose the 100,000 ringgits you went up there with. That there, you're going to donate it to the casino. The only casino I ever known that has gone broke, that there, is the ones owned by Donald Trump. Everybody else who's owned casinos has made millions and millions off of them, or billions, but Donald Trump managed to file bankruptcy owning a casino. But the game was played is that you throw 2 dice, and I mentioned the other day that when you throw 2 dice, that the probability of getting a 2 is very low, the probability of getting a 12 is very low. The highest probability is a 7, 6, or 8, right there. And then they drop off up there. And I'm not, you can go through and you can do a probability test on, if you throw 1,000, rolls of a dice, what would be the probability of getting each of those? And who knows, that might be on the final exam, the final project where I have you simulate throwing 1,000, throws of dice there. But the way the rule works is, if you throw a 2, 3, or 12 on the first roll, you automatically lose. Again, a 2, 12, and 3 are relatively low probability throws. So you're most likely not going to lose on the first throw, but you could. That there. If you throw a 4, 5, 6, 8, 9, or 10, then that becomes your point and you keep throwing. And if you throw a 7 or 11, they mentioned it up here. A 7 or 11 on the first throw, you win. So that there, someone who spent a lot of time studying probabilities and throwing that there came up with this game and these funky rules. So what this program is going to do, and I'm just going to kind of fly through it, that there is it goes through how you would play such a game. And there's an entire branch of computer science called game theory out there, where you write computer games to play, or programs to play various games. And this is one of them. That there's people who write computer programs that simulate poker. There's slot machines, and then there's computer games that simulate Monopoly, all kinds of board games. But game theory is a large part of computer science. People play a lot of games on their iPhones and their tablets and their PCs. So we start off here, and something brand new that we have not talked about is an enumerated type. And an enumerated type is one that we define what the possible values is. So in this particular case, continue, win, and loss are the only things that a variable of type status can have. But status is a data type, just like int, float, string, so it's not a variable. So we can have multiple variables of type status. In this case, we're going to have one. And we have not talked about enumerated types. And other types of enumerated types might be months of the year, where you define them as January, February, March. Class status for a college student, freshman, sophomore, junior, senior, which I don't know if you use those terms or not But enumerated type is a type that we've defined And we can define any kind of type So something that's defined as a variable that we say is of type status can only be continue, win, or loss. Right there. And then we've got one function in this program, and that's called roll dice. So we're going to go through here, and we're going to just kind of I'm just going to go through this. For those that just came in, I realize how little time I've got, so I'm going to kind of talk fast and and you may have to look at the book to figure out and ask questions. But first off, we call the function sran. We talked about that yesterday. That randomizes our random number generator. We declare a variable called myPoint. Remember the rules of the game. If I roll a 4, 5, 6, 8, 9, 10, that becomes your point in the game of craps right there, and again, that goes back to, the rules right there. So as I go through this discussion, you may have to, if you watch this on the tape, you have to go back and look at the rules, but But 4, 5, 6, 8, 9, 10, after the first throw we declare a point right there. So we also declare a variable called game status, and it's of type status. So game status is either we're going to continue the game and throw the dice once more, or we've lost the game, or we've won the game right there. So, and then we also have a variable called sum, and it's equal to roll dice. Now, roll dice is a function, so we initialize it the first roll of the dice right there. Then we look at what happens after the first throw. Remember, the first throw is 7 or 11, you win, so we use a case statement. 2, 3, or 4, we lost. That's there. Or if we get any other number, that's a default, we're going to continue the game. So our point is now whatever we rolled on our first throw, and we're going to print out the point is my point, and then break, that there. So that's the first roll. Then we go in and we keep rolling the dice. And we keep rolling the dice as long as the status is equal to continue. So I throw the dice a second time. If the sum is equal to that, to my point, I won the game. Else, if the sum is equal to 7, we lost the game. And we keep throwing until either we get a 7 or our point. So, for example, and I'm not going to spend a long time, but let's say I throw an 8 the first time, right? So I'm going to keep throwing. Then I throw a 6, I keep throwing. I throw a 9, I keep throwing. I throw a 10, I keep throwing. 11, I keep throwing. Now I throw an 8, I won right there. Let's say again, I throw an 8 right there. Then I throw a 6, then I throw a 9, then I throw a 7. At this point, I lost right there. On the first row, if I threw a 2, I lost. If I throw a 12, I lost. If I throw an 11, that becomes a win, right? If I throw a 7, that's a win. So the number 7 is kind of a strange number in the game of craps. If you throw it on the first throw, you win the game. But you throw it on the second throw, you lose the game. That's there. And remember, this is the most common number that you throw. So that's there. So else, and then we print if 1 equals game status, player wins. Else, if the that's there. Else, you either win or you lose, and that's the whole program. I'm not going to go into it in more detail than that. That's there. So there's our function roll dice. Now remember, you cannot do one random number between 2 and 12 because the probability is wrong. Right there. You have to do 2 dice separately. So, and the function for a random number is that there, and that's all that there. Usually this is the starting number right there, 1 plus, and this is the number of possibilities right there. And there, so, and this prints the number rolled each time through, so you keep track of what you roll right there. So if you encoded this game, it would just, and you play it one time, it'll show all the rolls it takes before you win or lose. And I have been known to give this as a homework assignment or a semester or a midterm project in the past, where I have a person play 1,000 games and see how many they win or lose. But I won't do this with this class out there. So, out there. And this is an example of some plays right there. Again, they're showing that on the first throw, they got an 11, they win. Then the second time they play the game, they got a 5, so the point is 5. And they throw 3 more times and they get a 5, they win. So actually, this is not typical of actually playing the game of craps. You play twice and you win, but right here. And then you've got here, you throw a 2, you lost. You throw a 10, and then you got a 7 before you hit a 10, so you end up losing right there. So, but that's typical of game theory, and there's and at there, this particular game, is one that you can play it without gambling. Like I said, it's a popular casino game that there you see it on TV whenever you got the big table where people are throwing the dice, and people are blowing on the dice and throwing them. This is the game they're playing right there. But if you look at the game, you always lose more than you win. That's there. Okay, so I'm going to just kind of skip through all this right here. I'm skipping storage classes right there. That's there. This is not necessarily unimportant material where we can declare variables as external and static and things like that, but for sake of this class, I'm going to skip it. It's more of an advanced topic right there. I'm going to only mention one more thing from this chapter. And again, I did talk about, and I'm going to kind of point this out, I did mention earlier the concept of global variables. This is where you would put the global variable outside of main and outside of any function right there. So C can get very, very confusing when you look at scope of variables. And I don't want to get into that topic because this is almost a short course in C, as if you're looking at the fact that the book has got 15 chapters, and I'm going to finish after about the first 20 pages of chapter 6, which means I've only covered just over a third of the book. So, and I've skipped a number of things, but we've got basically 10 weeks to spend on C, and I normally spend a good 16-week semester on C, so that there. So, but that there. So I'm going to kind of skip I want to mention recursion, and recursion is a function that calls itself. Not all languages support recursion right there, but it's a complex subject discussed at length in upper level computer science courses. In other words, it can be very messy, but you have to be careful with recursion. That's all right. We started without you. I started without a lot of people. I think there was 2 people in here when I started that there. But recursion has 2 things you have to be careful. One is you have to have a way out of a recursive function, because it keeps calling itself right there. So it's that there, and you'll see what I mean. So, and because it can call itself many times, it uses a lot of the stack. And I mentioned the stack, and I didn't get into great detail, but variables are pushed onto the stack every time we call a function. So if I have a function that keeps calling itself over and over again, I may blow up the stack unless I provide a path out right there. There's 2 types of recursion. One is direct, and that's what I'm going to talk about here. One is indirect. And what I mean by indirect is I have function, I call function A. B equals A, and I pass the K, for example, right there. So A is a function right here. So down here in int A, it receives int X right there. And I'm going to say return and I'm going to call function B right here, X right there. So, but B, int B, and int B right there, and it receives int Y, and somewhere in here I say that L is equal to A Y, for example, right there. Well, what is happening here is main calls A calls B right here, and then B turns right around and calls A again. So A is calling itself indirectly through B. That's indirect recursion. That can be very dangerous because you don't realize you're doing it, and it can cause an infinite loop and create all kinds of problems right there. What this chapter talks more about is direct recursion, where A calls itself, and we'll see an example of that here in a second right there. And I'm not going to go through the example, but where if I wanted to do a calculation, I can call the same function, only I pass it something else. That's there. And recursion is called, this function is called that's there. Yeah, let me go up there. I'm going to jump through there and just jump to the example right here. And here's an example right here. Factorial right there. 5 factorial is 5 times 4 times 3 times 2 times 1. Well, 4 factorial is 4 times 3 times 2 times 1. So I could say that 5 factorial is equal to 5 times 4 factorial. I could say that 4 factorial is 4 times 3 factorial. So I can do a calculation here. You know, this is showing doing it with the normal way with a for loop. But with recursion, what I can do here is say 5 is equal to 5 times 4 factorial, right there. So I can write a very simple function right there that has one line, right? And that has one line there, and it says return number times factorial n minus 1. So this is the function right there. Is here's main, and I'm going to print out factorial I, and this does the factorial of 1 to 21, right? 0 to 21, right there. And that there, so we call the function factorial. But the function factorial calls factorial, right there. So we've got this function right here, factorial, that calls factorial. Now this is unsigned long int. In other words, because factorial, 21 factorial is a big number. That's why they made it return such a large number right there. Right there. So, right there, we're going to print that as a long unsigned int right there. But this is that there. And if you look at the first section, it says if number is less than or equal to 1, return 1. So in other words, 0 factorial is, the answer is 1, right there. So, but this is going to, so this is my way out, right there. So we call it, we keep calling it, but every time we call it, we subtract 1. The first time we call it, let's say we're going to send a 5 to it, right there. We call factorial 5, right there. So that goes into that there. So, but that's going to return 5 times fact 4, right there. So that's going to call factorial, and that's going to return 3 times fact 2, right? And that's going to return 2 times fact 1. Now, this is going to return a 1. That's there. So then we start backtracking our way back out of this, right there. So in other words, we call factorial 5, right there. We have one call, the initial call, second call, third call, fourth call, the fifth call. Now, if I call factorial 21 as the program does, it's going to call itself 21 times, right there. So obviously, if we're starting to do relatively large numbers, 21 function calls in the running through there, if you're running on a microcontroller, is likely to blow out the stack. On a desktop computer, you're okay. That's there. So it's something you got to be careful of, right there. So this is what you got. 0 factorial is 1, 1 factorial is 1, and we go through here, and 5 factorial is 120, and this is recursion. Right there. It's something that is not used a lot, but it is used a lot in some areas. When you get into pointers, in which we won't get into pointers, it's used a great deal there. So, you can spend a lot of time on recursion. And as I said, this is a kind of short course. I'm going to kind of wrap up that there. But again, the key thing is that you Another example is the Fibonacci series, where it begins with 0 and 1, and then it's the sum of the previous two numbers. So you just keep going that there. And again, Fibonacci is equal to Fibonacci n minus 1 plus n minus 2. And of course, 0, and you keep going through that there. And our final case there is n 0 is equal to n, or 1, return n. Otherwise, keep calling it back right there. So I'm going to kind of wrap up this chapter at this point here, and I'm going to spend a little bit of time talking about the next chapter right there. And we're not going to spend as much time as I'd like to, because like I said, I'm going to finish up C with my discussion on arrays, which is actually a good place because MATLAB deals with matrices and arrays very well. So we'll talk about how we do array, what an array is, and how it works in C. And then after the break, we'll come back and look at how it's done in MATLAB right there. So, there's a few other topics I wish I could get to. It's just that we just don't have time right there. So, now I'll talk about that possibly later. Right there. So an array structure, we'll look at lists and tables out there. So we'll look at how we look at various parts of an array, how we declare them. Now MATLAB actually does arrays much easier than C. So as I talk about that there, and I will try to get up to where I talk about a 2x2 array, which is a table right there. So I'll probably skip the searches right there. And so if we had time, I would jump to chapter 10 and talk about structures. That's another topic that I would like to have covered, and I may come back to that to find what a structure is, because MATLAB has structures as well, right there. So, and that's where you have more than one data type within a variable, and we can have arrays of structures, and that gets very, very colorful. Is in fun right there. Arrays of structures are static; they remain the same throughout program execution. In other words, they're not wiped out. That there. An array is a continuous memory location that has the same type right there. So I can have the easiest way of defining an array is I have 31 students in a class or 12 students in a class, and each one of them has this much money in their bank accounts. A couple of these folks are fairly rich. Student 10 has got 6,453 ringgits in his account. Student 0 is overdrafted by 45 ringgits. He owes the bank 45 ringgits. Student 5 seems to be the brokest student. He's overdrafted by 89 ringgits out there. But these are all various values that's there. And if we deal with a structure that there, then we could look at it as an apartment building that has 12 floors and has 5 apartments in each floor, right there. So, but again, this is a 12-element array. That there. The first element is the 0. Array name follows the same rules as every other variable. You use square brackets to give the index or subscript right there. So an index must be an integer or an integer expression. So you cannot use floating point that there. There's not a student 3.5 right there. There's a student 0, there's a student 1, there's a student 2, student 3, and a student 4. But there's no 3.5 students right there. So we can say that if A is 5 and B is 6, so this right here is an integer equivalent. A plus B is the number 11. So this points to the 11th element of the array, and we're going to add 2 to that right there. So there are 12 elements up there, and again, this is here. We can print out the sum of 3 elements of the array. We can go through and do a loop and calculate the sum of the entire array there. And in a few minutes, we'll see that right there. So the brackets are actually considered to be an operator there. So you calculate the value of what's inside the brackets before you do anything else in an equation. Right there is what they're saying. So brackets and parentheses are considered at the same level in terms of order of precedence, what's done first. Right there. We define an array relatively simple. C int, C12. That means that C has 12 elements, 0 through 11. Some languages start with 1. That's there. Some start with, C starts with 0. Right there. Keep in mind, if you're working with BASIC, it starts with 12. It starts with, it'll go from C1 to C12, right there. So, in some languages, use the parentheses around the indexes. C uses brackets right there. So, here we define 2 arrays. B has 100 elements. X has 27, right there. So, we can have right here, we can go through, and arrays often use loops. Here we go for I is from 0 to 4, right there, because n is 5, and we set n equal to 0, right there, and print the contents of arrays in tabular form. This is just simply a print right there. So this prints I and then the value of ni. So this goes through right here and initializes there. So that just goes through and prints out the various values. For loops are used a lot in array processing. Right there. So an array example right there, and I'm not going to here. We can initialize our array when we declare it. So we say int 5 bracket 5 or int n bracket 5 close bracket, and we give it the 5 values of n right there. And there, if we do that, we make sure we have to list all 5 values. Python lets you get away with only listing 4 of them, and then assigns a 0 to the 5th one. But C requires that all the elements be processed right there. So we can initialize the entire array to 0 right there. So 0 is the exception right there. So if you were at there, the remaining, it does say fewer initializers, it does initialize to 0. I'm thinking of an older version of C right there. So evidently they changed it. Don't count on that. Normally, if you're going to do this, make sure you initialize all of them at there. But evidently, C, they're saying that if you only put 2 in there, they're going to initialize the rest to 0. Right? So remember that arrays are not automatically initialized to 0. That is a very important thing, is that when you initialize an array, or when you declare an array, it's going to set aside a place in memory. And that memory may not be empty. It may have some value left over from some previous function, program or something that there. So if you initialize an array, normally you would want to 0 it out beforehand. So array elements are initialized before. Static or automatic at there. We won't get into that there. So at there, here, this is where you do have an error because you define this as an array of 5 and you have 6 values there. It doesn't know what to do with the 14. That'll give you a syntax error right there. Now, you could, in this particular case, you can initialize a variable and leave this empty, and this will initialize it to five values because of there. As it turns out, you can actually leave it empty, and it will just allocate whatever space it thinks you need. That there. So there. So here's an example where we're setting up and we're doing that there. And again, I'm kind of flying through this chapter relatively quick, but we're going to see a lot more of arrays in MATLAB. I'm just trying to introduce here. But we set 5 as a variable, right? Or as a constant right here, defined size. It's a constant. And I mentioned that we could set constants outside the main program that they're defined there. The example I used was GST rate was a constant. Here we're size is a constant, defined size is 5. And we declare an array that has size elements or 5 elements right there. And here we're using size as our constant right there for our our final value there. So we're going to say that Sj, which goes from 0 to 4 in this case, is equal to 2 times 2 times j right there. So this just simply sets up an array. The first value is going to be 0 or 2. Then the second one's going to be 2 plus 2, so it'll be 4, and then there on out, and here's our value. There's our table right there. So there, as I said, I'm kind of flying through this chapter. Not that it's not important, but because it's going to be a lot of it's going to be repeated right there. Here's another one where we're going to count frequencies right there. So here our size is going to be 11. And what this particular program does is it's got 40 values between 0 and 11. And we're just going to add up how many that there. And you might want to do this, for example, if you had, instead of initializing our array of responses and giving all that, we're going to go through and we're going to do 40 throws of dice, which has a value between 1 and 12 right there. So 2 and 12 right there. So we would have an array, but we just simply go through here, and all we have to do is say size goes from 0 to the number of responses size, which is 40 responses. There, an answer right there, and the frequency of the answers is going to be equal to that there. We use whatever we read as our subscript right there. Example of this might be, and I'm only going to mention this because this is a typical problem that I got. Let's say, for example, I'm going to do the Happy Meal problem right there. And the Happy Meal problem means that you've got 13 states in Malaysia. We'll throw away the federal territories right there. We're only going to look at the 13 states, right? And we're going to say that the first state is, and I'm just going to pick one, and we're going to say Johor is state 0 right there. We'll say, can't remember now, I'm just going to say Selangor is state 1, and blah, 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 all the way to Kelantan is state 12 right there. So, and I'm going to buy a Happy Meal right there, and my Happy Meal is going to have a flag in it right there. And we're going to have a flag for one of these states right there. So I'm going to buy 1,000 Happy Meals, and how many of each state do I have, right there. And I keep buying Happy Meals until I've got all the states, right there. So this is probably a hint of what I'll probably use for the, because because you have a course project you have to do the last few weeks while after we're done meeting, and it'll have a C part to it and it'll have a MATLAB part. And this will probably be the C part, so you might want to start thinking about the fact that I'm going to go into McDonald's and buy a Happy Meal, and I'm going to get some kind of prize that I was going to have up there. And I could do it with football teams. I'll assume that that we've got a soccer ball with the state symbol on it, that flag on it, that there. And you'll have that just before the Malaysian tournament. And I know that they have a tournament because Slangor won it a couple of years ago, and they declared a state holiday at there. It was right at the end of the semester, if I remember right. But again, we've got that's an example that you'll probably see again right there. And this is the same type of thing, only instead of our responses here being in we'll have a random number generator that'll generate a random number between 0 and 12, and that tells you which Happy Meal you bought, which soccer ball you got with your Happy Meal, that there, and you just simply keep track of all the states, and then you have a little routine that checks to see if any of them are 0, then which means you continue, much like the craps game, right there. You just go through and check array, and then go through the array 0 through 12, and if any of them is equal to 0, in other words, you haven't got that ball yet, you keep buying Happy Meals, right there. We'll talk about that later, but again, you'll see this in the final project, something similar to that there. So here we did a between 0 and 0, that they're analyzing the student poll right there, and I'm not sure, rating from 1 to less than the frequency size right there. So this goes between 1 and 10 right there. They didn't allow any 0 responses right there. That was the key here. They had no 0 responses. So it's all the responses are between 1 and 10, not 0 and there. So because we had 10 right there. So the average, the most common score was 6 right there. So we can go through, and they go through, and frequencies right there. The key is right there, and I'm not going to go through read that there. We can do a histogram, and it looks like that there. This is a different problem right here, because here our size is only 5, and it goes from 19, 3, 5, and 11. So we've got, it looks like a number, 19 stars, 3 stars, 15 stars, 7 stars. This is the way that we used to plot back in the old days with these little bar graphs up there. So rolling 60,000 dice, summarizing in an array. Again, we do the same thing we talked about here. We're going to throw 6 million, I guess it's 6 million throws, and it comes up with our frequency. We did the same thing before, but we kept track of the frequency in an array in this particular case. Same example as before, only instead of adding 1 to that right there, we just simply increment the array. It's a little easier right there. So strings are actually arrays of characters right there. So we can look at there. If we had more time in the course, we would go through the chapter on processing strings and characters. But a string is actually an array. The word hello is the 5 chars for HELLO, and then a final char for the null character to say an end of string. right there. So it actually has one extra character, which is the /0. And I've done problems where I had to dissect strings and look for certain values and manipulate strings. That's a very common thing when you're dealing with embedded systems, is processing strings right there. We won't do much with strings here and there. But again, here we can say char string is the same thing right there. So now I'm going to kind of skip through this right here, right there, and I want to jump to our two-dimensional arrays. Passing arrays of functions right there. We can pass a single element. If we pass the entire array, we're passing the address of the array. So you got to be careful. If we pass an array to a function, it changes the data in the original function right there. So when the call function modifies the array elements, it's modifying it in the original memory location. So you've got to be careful of that there. I talked about the fact that if we pass an array, we're essentially passing the address of element 0 right there. And we haven't really talked about pointers and the book hasn't covered pointers yet, but I don't know why he's talking about pointers. So again, he's looking here is that we're printing out that fact that we have the address of the array right there. So if we pass one piece of data, then we're passing it by value right there. So here we're void modify array, we're passing at the array right there. This particular function does not return anything because what we're doing is we're changing the data in the array. So we don't have to pass, we don't have to return anything that's there. So that's there. But as we change the array, it changes it throughout the whole program right there. So here's our modify. Again, we're going to we have an array that's 5. We're initializing that there. We print the array, and then we call a function called, if we modify element 3, that doesn't change the value right there. Because it's by value. But if we pass the entire array, then we change its value right there. So that's there. Okay, I want to jump. I'm not going to talk about sorting arrays. That's a very important topic in some courses, more so in computer science than it is in engineering, but we may want to sort an array, put it in order. They use what's called a bubble sort, a quick sort. There's all kinds of sorting routines. If you need to sort an array, look it up in any book, you'll find, how to sort an array if you run into that problem in real life. I've had to sort a lot of arrays by that. So I'm going to skip that there. Calculating the mean, right there. The mean is the middle, is the average. The median is the middle value. And the mode, I can't remember what the mode is. I'm not a statistics person. Mean and median I know real well, but that's there. But here's an array, and the mean, median, and mode right there. The mean is the average value. That's there. The median is the middle value right there. And what is the most frequent value is the, that's what I was thinking it was right there. So, that's there. But this is an interesting program because it shows the bubble sort subroutine. And if you ever have to sort an array, you can use the bubble sort. It goes through and it compares the first two, then the second two, and then keeps going until it doesn't do any swaps right there. But that there keeps track of the mode. Again, is the most frequent value right there. So we go through the array and we look for the largest number of there. The mode, of course, is the middle one. So example of the mode is if I take all the people that live in KL and I calculate the average house value, the value of the average home in KL, that number is skewed because of the fact there's some multi-million dollar homes, in the KL area. It's also skewed by the fact that there's some very, very low cost homes out there. But if I look at the median value that is 50% of the people in KL live in a home that's cheaper, 50% live in a home that's more expensive. So that's more of what you would expect to find for a typical home. And the last one is the one that I couldn't remember off the top of my head. The mode is the one that the most people live in. Now, if you look in KL, you would find possibly the most people live in the low-cost flats. You may have more people in low-cost flats than you do luxury condos. But the median might be somewhere in between not a low-cost flat, but it might be a median cost apartment or something like that. So you've got these various values, but this program goes through that. And I'm not going to necessarily go through this in great detail. Again, we'll see this more in MATLAB right there. So the median, there is 7 right here. In this particular case, the mean value turns out to be close to that there. And the mode turns out to be 8 in this particular case. So there's 3 different numbers. They mean 3 different things. Statisticians or mathematicians, that they're social scientists really get into these various median, mode, and mean. They look at those 3 values when they analyze incomes, and when they analyze salaries, when they analyze property values. As an engineer, we don't necessarily get into those as much right there. So there's a case study, and again, we're searching arrays. If an array is sorted, then you can use what's called a quick search. Otherwise, you go through. So quite often we would do searches. Again, I'm flying through this chapter. Not spent there. Searches actually come into bigger play when we have structures, which we're not going to cover, or we're searching an entire bank full of accounts looking for a particular account number or looking for a particular customer right there. So we have to search through all the data in the data set right there. So again, I'm not going to get into that, but if an array is sorted, we can use the binary search. All right. The last topic I'm going to talk about for C, and it's one that's going to come back a great deal when we get into MATLAB, is a table or a 2-dimensional array. And another word for a 2-dimensional array you might hear is a matrix right there. Matrices are very commonly used in data processing. They're very commonly used in circuit analysis. They're very commonly used in a number of places right there. So, and we'll look at some circuit analysis problems when we get into MATLAB. We'll be using arrays and calculating that there. But an array is like an apartment building. If you look at an apartment building that has 5 floors, G1, 2, 3, 4, right there. And you have 5 apartments on each floor, right there. I'm not going to show all 5. You could say that somebody lives in apartment 2, 3. That means they live on the 2nd floor in apartment 3, right there. So we can look at an arrays in that way, right there. I have 20 students. I'm not going to show all that there. I'm going to call it grades. And we have 2, 4. This is student number 2. And this is their grade on the 4th exam, right there. So we can have a table like that there. So we recognize that there. Again, we're going to get into more of this in MATLAB. We can have 3-dimensional arrays, right there, where I can have 2. So this is the grade on the 4th test. This is the second problem on test 4 for student 2, right there. So we can dig deeper into that there. So, we can look at temperatures right there, and we could have 2, 12. Actually, I'm doing this backwards. This should be 12, 2, 21. This is temperature on the 2nd or the 12th of February at 9 p.m. right there. So we can look at that there. We can put another number here. We want to get in that there at 23, so we could say at 9:23 p.m. right there. So you can see where we can get multiple dimensional arrays right there. So we can dig as deep as we want in terms of declaring our arrays right there. So the most we're going to deal with in this class, and we'll deal with it in MATLAB more than we will C. We won't do any matrix problems in C. That's there, because I've already told you what your chances are, what the problem's going to look like as a 1-dimensional array. It won't be a 2-dimensional array, right there. But we can look at the fact that we can declare 2-dimensional arrays right there, and each element has so many, that's the rows and columns right there. And here we define a 2-by-2 array. So, row 1 is 2, 1, and 2. Row 2 is, row 0 is 1 and 2. Row 1 is 3 and 4 right there. So that's there. And we could get in that there. I just want to kind of mention what 2-dimensional arrays are right there. Again, this is an example of it there. And I think here we can, and typically if you're dealing with 2-dimensional arrays, I should point out is that quite often you'll have in this particular case, here's a software program dealing with a 2-dimensional array, you're going to have a embedded for loop. So here's the outer loop, and here's an inner loop. So this goes through here, and I is the element for the outer loop. So this zeroes out. Every time I go into the center loop, I zero out 1 row. Then we increment this and we do the next row. So we normally have a embedded for loop when we have 2-dimensional arrays right there. I almost forgot that there. So as you can see here, we have our nested for loop. This for loop is completely nested inside of this outer loop. That there. So as you can see, as we deal with two-dimensional arrays, and they get larger and larger. And if we have a four-dimensional array, of course, we could have 3 nested for loops within each other right there. So they can get very messy when you get into 3 and 4-dimensional arrays. This book only talks about 2-dimensional, but you can get into multi-dimensional right there. And I'm not going to, this goes through here. We've got 3 students with 4 exams, and this is a program that calculates the average of each student. We can go through there and look at low grade, high grades. This is a fairly nasty program that there with the average grade. The lowest grade is 68, the highest grade is 96. Average for students 0, 1, and 2, right there. And this would be how you would process. And people that do data reporting, for example, at the end of the semester, for this semester, for this class, I said that there's so many assignments and I've assigned so many points for each one, right there. And as you look at that there, I put grades into the computer system, into the system there for each assignment, each grade. And then at the end of the semester, the software will calculate what your grade is based on the grading scale. It'll also give what the student average is, how many A's, how many B's, how many C's. That's all done in the student, the registration software. But somebody had to write that. And it was written using these techniques right there. So again, I think that almost wraps up this chapter. You can have variable rate or size length arrays. That's there, where you just simply declare the array. In this particular case, we scanf and we initialize the array. That's there. We can also have arrays that have variable size, and that gets really messy. We're not going to deal with that. That's there. So I'm going to kind of skip through that there. Bounds checking. You should always check to make sure you're within the range. Scanf right there. And that's going to wrap up our discussion on C. That's the fastest I covered any chapter, I think. Out there. I'm not too worried about that because the arrays are covered a great deal in MATLAB. So have a great semester break. I guess I'll see you a week from yesterday, 2 weeks from yesterday, right? You'll all be going back home and eating mom's cooking and sleeping in your own beds and relaxing, visiting with all your friends and your siblings that they're fighting with some of your siblings in some cases, right? That there, if you have younger brothers and sisters, you probably get to go home and pick on them a little bit, right? That there. I mean, at least I'm the oldest in the family, so I definitely picked on my sister a great deal. That there, so that there. Of course, I picked on my kids too. That's why they're probably still mad at me at times. That there. But regardless, have a good time. That there. Anybody who's driving or taking a bike home, be safe. I talked to a couple of students from time to time that ride their little motorcycles up and down the north-south highway all the way to Johor or someplace. That there, if you're doing that, be careful. That there. So I will see you. We will come back.